In this lesson, we will learn how to solve inequalities and systems of inequalities in two variables. The solution for a system of inequalities is usually a shaded region of the coordinate plane. So let's go down to this example here and see what it means to be a solution and how we can express it. So first of all, we're asked to identify if these 3 points are solutions to this inequality. We can do that algebraically by just plugging it in and see if we get a true or false statement. So for A, the origin, the point 0, 0, what I'm going to do is plug 0 in for X and 0 in for Y and see if the resulting statement is true or false. Well, 3 times 0 is 0, 2 times 0 is 0, and 0 minus 0 is 0. So is that less than or equal to 6? Yes. So this is true. Let's look at the point B, which is negative 2, 3. So I will plug negative 2 in for X. I will plug 3 in for Y and see if the resulting statement is true or false. So 3 times negative 2 is negative 6. Negative 2 times 3 would give me minus 6. And negative 6 minus 6 is negative 12. Since negative 12 is less than 6, this is another true statement. Finally, let's look at point C. So point C is the point 4, 1. So I will plug in 4 for X, 1 for Y, and see if I get a true statement. So that would give me 12 minus 2, which is 10. 10 is not less than or equal to 6, so this is false. So the A and B are solutions, but C is not. So that leads us to the question, how can we express the solution to an inequality in two variables? Since you may have more than one point, like we did here, be a solution, then the solution to an inequality in two variables is a shaded region of the coordinate plane. Like I said before, in which all of the ordered pairs that satisfy the inequality reside. The related, or let me say this, the equation related to the inequality or equations serve as boundaries to this shaded region. So let's look at our example 2 above. We had the inequality 3x minus 2y is less than or equal to 6. We already know that the origin and the point -2, 3 are solutions, but those aren't the only solutions. So to show the solutions, what I'm first going to do is graph the boundary. And in this case, it's a line, which is 3x minus 2y equals 6. Now to graph this, I can either solve it for y and put it in slope-intercept form, or I can find the x and y intercepts. Since this is in standard form, it's easier to find the x and y intercepts. So to find the x-intercept, remember you plug 0 in for y, and so that would give me 3x equals 6, because the term with y in it will go away, because -2 times 0 is 0, and x is equal to 2. So we have 2, 0 as the x-intercept, and the y-intercept, we do the opposite. We let x equal 0, which means the term with x in it will disappear, and that will give me y equals -3. So our x-intercept is 2, 0, and our y-intercept is 0, -3. So I'm going to plot the point 2, 0. I'm going to plot the point 0, -3, and this is my boundary line. Now, before I draw that line, I want to draw our attention to the directions up here. So when you're drawing the boundary lines, or curves, if it's a parabola, then if the inequality has a less than or greater than but no equals to, you're going to graph it with a dashed line, kind of like we use an open circle or parentheses in interval notation. And if the inequality has the equals to, so it's less than or equal to or greater than or equal to, then we will draw it with a solid line, kind of like we do a filled-in circle on a number line, or like we use brackets in interval notation. So this inequality contains the equals to, so we're going to graph with a solid line. So I'm going to connect these 2 points with a, I'm trying to do this a little better, with a solid line. And what this line does is it divides the coordinate plane into a region that works and a region that doesn't. And so to figure out which region works, that's hard to say, we look at the ordered pairs that did work. So 0, 0 worked, it's over here. -2, 3 worked, it's over here. And if any point on this side of that line works, they all do. So the solution is going to be the shaded region above the line, or on this side of the line. So what that means is we can pick any point on this side in this region and it will satisfy this inequality. Now notice that the third point, which was 4, 1, 1, 2, 3, 4, 1, that point 2, 3, is here. And that's on the other side. It did not work. So that means no points over here will work. So this is the solution to that inequality in 2 variables. It is this shaded region.